Hi, let's start class. Well, today we are going to study geometry. We have three lessons on the geometry. This is the first step to geometry. Okay, maybe you were told that you will study geometry in high school, but we have a different levels geometry. Okay, and today's geometry is about triangles and rectangles. Well, in order to understand the rectangles, we also should understand the triangles. Conversely, if you understand triangles, you can understand a rectangle. Yeah, rectangle triangles just almost, you can make rectangles using triangles. Okay. Well, special triangles. Let me talk about special triangle first. Special triangle is a triangle we call right triangle. Okay. Then white, this is special triangle. It's a right triangle, right? You heard about right triangle. The most important thing for the right triangle is the relationship of the three sides. Okay, the three sides. This side is A, that side is B, is a C, and we have the formula called Pythagorean theory. Okay, the Pythagorean theory says that a triangle is a right triangle if only C squared plus A squared plus B squared. So it is a right. So it's vice versa. So it is a right triangle. Mean if and only if C squared equals A squared plus B squared. Okay. Now this is a interesting formula. So one of the most important formulas discovered by a human being. Okay. So earlier, a couple thousand years ago, and Chinese discovered that there was a special triangle, and this side is 3, other side 4, then this side is a 5. Okay, so I ask, ask a child to trying to figure out what is how long the other side, and many students probably can figure it out about 5, because you draw a triangle, right triangle, and the one side you like 3 inches, other side 4 inches, then you measure the length of the diagonal, then the hypotenuse, right? Then you find out it's exactly 5. Then you try many times, you find that it's always true. Then you discover that also Chinese recorded this discovery, but they did not continue to get the general formula. Okay, that's why it's not, otherwise it's called the Chinese theory, not the Pythagorean theory. Okay, maybe the reason is the languages are used to represent mathematics. In mathematics, is not perfect, so it's harder to easily write variables like that. A and B is so simple to write, right? Otherwise, if you look at the statement for this special case in Chinese, it's hard to read it. Okay, and so they did not continue to discover this. Then, then, people in Europe, East Europe, they discover a few more, and then they prove this is true in general. Okay, so whenever you see this relationship, C squared equals A squared plus B squared, and this is a right triangle. Now, and we are more interested in those right triangles was integer sides. Okay, so each sides are integer. Okay, so can you name the next one? Right? So I remember, there are lots of them. Okay, if you if this side is 3, this side is 12. In order to make this one a right triangle, what is the other side? Yeah. 11? No. Don't guess. You have to calculate based on the above formula. It is right triangle A squared plus B squared should be equal to C squared, right? So it's A, right? And this is a C, right? So A squared plus 12 squared equals 13 squared. Okay, and then A squared equals 113 squared is 169, 144, right? 12 squared, right? And that's equal to 25, right? Yeah. So A should be equal to 5. Then you will see, now a good researcher, okay, scientist will ask, can I find many right triangles in this way? No, integer length. You see, one side is 13, other side 12, it differed by 1, right? And here 4 and 5 also differ by 1. So then you actually can find many if you use this idea. So can you list, few more? That's why you have to do research, right? And I had one student, and he was a 6th grade student. I didn't ask him to do that, and he see he sees that, he noticed that. I didn't even mention. He noticed, this one side is 13, other side 12. Maybe I can find another one, that differ by 1. Then he find the general formula even. I can list the 100 if I use my formula. See, then he has this talent of being a scientist. Okay, I don't need to ask you to do that. When you see that, you should think about this, right? Find a connection. When you see individual phenomena, right? And you should be alert. Then you find the connection, find the relationship. Then you make a conjecture. Then you try to verify that. Okay, being a biologist also like you do, you discover something, but it's individual case, and you discover similar one. Then you probably jump to the conclusion. Okay, so this is maybe you can find another one, but this is this is the right triangle. We find it. Okay, now I'm going to jump to a rectangle first, and we come back to triangle. Okay, we have a rectangle, right? Rectangle. If you divide by 2, you get 2 right triangles. Okay, if you understand right triangle, you understand the rectangles. Rectangle is just, okay, but this rectangle, okay, and this side is C, right? What we should know about rectangle? One is we should know how large of this rectangle means. We have to introduce a concept called area, okay? Because you have some cakes, right, and different shape, but they're all rectangle, and you want to know how large of the cake you're gonna get. You make a choice. Like I put two cakes on the table. They're also in rectangle shape, right? And then how do you know your one is large? Sometimes it's hard to tell difference, but sometimes we differ by a little bit. But you still want to know which one is larger, right? Then you have to introduce a concept called area. So area is going to be A times B. That was introduced by this quantity, is introduced by human being. Okay, we just introduce, it's not, we did not create, we just trying to name this. Okay, the product of those 2 numbers indeed tells you how large of this cake. Okay, so that is it. But sometimes also we want to know the length around this rectangle, and that's called parameter. Why we needed to know that? Because you want to build a vegetable garden, rectangular, right? And you want to know how long a fence you're going to purchase and put there, right? So it's important. That is a cost for you, right? So this is a parameter. The parameter is you have a double A and a double B, okay? And what else? We also want to know about rectangle, about the diagonal, the length of the diagonal, right? Sometimes you want to go from this side to the other side, on the diagonal side. So this is the length of the diagonal, okay? Yeah, diagonal length, okay? So diagonal length, I'm going to call the D. So D is going to be, by the Pythagorean theory. This is where we use the Pythagorean theory. It's going to be square root of A squared plus B squared. Okay, so that's the square. They involve the square root. Now, what does it mean, square root, right? Square root is just to represent the number whose square is going to be A squared plus B squared. The special case, what is the square root of a number, right? What is this number? Okay, this square root of number probably is not the integer, but this is the number, okay? Is the number is a positive number, okay? Whose square is 8, okay? So square root 2, okay? Square root 2 is a number, first of all, it's positive, right? It is positive. Second number, it's a square, should be equal to 2, okay? So that is the number. How large is this number? You can use a calculator to check how large is this number. It's irrational number. It cannot be expressed as even fraction, integer of another integer, okay? But I can tell you the geometric meaning of this square root 2, okay? Look at this unit square, okay? Unit square is 1 and 1. You know, you want to know how large of the square root 2? And if you calculate the diagonal, the length of the diagonal, by the Pythagorean theory, d square is 1 square plus 1 square, which is 2, right? And then d should be equal to square root 2. Okay, this is so you want to estimate. If nobody told you how large is square root 2, you draw the unit square. You use a ruler to check, and you get a rough estimate of the number. Okay, right? It's about like a 1.14 something. Okay, so it's about 1.14. You know, it's irrational. Okay, so this is a meaning of the geometry meaning of the square root 2. Now, can you use a rectangle to describe square root 5? Yeah, square root 5, you can do like this. Double, and here's 2, here's 1, okay? Then you get this, and this will be square root of 5. Why? Why? Because this is d, right? Yeah, so d square equals 1 square plus 2 square, which is 5. So d is should be denoted by square root of 5, okay, which is some number related to 5. It's a square, it should be equal to 5, okay? And I don't remember the rough estimate, but you can use a calculator, can quickly check that, okay? But that you should know square root of 5 is larger than 2, right? Yeah, sometimes you do need a rough estimate. It's greater than 2. It's a square root of 5, okay? Then all right, so I have a question to ask you. I have a square. It's a square, okay? Okay, and this is the d, okay? So I know that if the area of the square is I just name any variables. If the area of the square is going to be 25 square units, square centimeters, what is the length of the diagonal? Hmm? Right? You have to do some computation. You know, the picture is there, right? Yeah. If don't just guess. Okay. Yeah, you have to don't just sit there. You know, write down the numbers, and you find there's a. Okay, I got square root of 50. Yeah. Okay. So this is the A, right? This is the A. We don't know what is that. So we don't need to know. So area is going to be A times A square, right? I know this is going to be 25, right? So A should be equal to 5. So edge length is 5. That's a two-step problem we call. Then you find out the length of the diagonal, right? The length of the diagonal is going to be a square plus a square. So actually, you don't need to even solve a, just the top of the area. Okay, so it's going to be 50. Okay, then the length of the diagonal is the square root of 50. Okay, so it's two-step problem. You're not given this edge length. You have to find out by yourself. Okay. My another problem is, yeah, let's focus on the square first. Okay. My another problem is if the parameter of a square is 18 centimeter long, and what is the area? Right. You express the area as a fraction. Express area, right? Hmm? Yeah. Well, yes. So we're talking about square, right? So we always express the edge length by a. Okay. So parameter of a square is going to be 4a because it's right 4 sides there, which is going to be 18. So you get a equals 18 over 4, and that is going to be a 9 over 2. Okay. Then the area is going to be a square, which is 9 over 2 square. That's 81 over 4. Okay. And the square centimeter, don't forget the units. That's the easy part. Let's go back to the rectangle. We just learned, right? We learned that the percentage problem, right? You did the homework, right? It's increased, yeah, 20% by the decreased, something. So this is a good question. Rectangle, okay? You have a length and the width, right? So this is width, that's the length, okay? If the length is decreased by 10%, and the width is increased by 10%, okay? By how much? What percent? By how much is the area change? Maybe your answer is no change. It's okay, without even doing any computation. So no change. Right? I just see some answers like that. It's more likely we'll get some conclusion because you change both sides. It's a rectangle, right? Increase, decrease, right? But if you really deeply understand the percent, increase by %, decrease by, then you probably will not jump to this conclusion. Okay. Sometimes length at the 1 inch, the width, right, decrease by 1 inch. Then the difference problem. Okay. Increase or decrease first? It's decreased, right? We are doing a geometry problem, so we have to draw the picture, right? So some students get, yeah, decreased. Okay, Benjamin says decrease. Okay, so you get length is decreased, width is increased. So let's draw this. Right, it looks like a larger, right? This is a prime, this is air prime. Okay, let's figure it out. The width is increased by 10%. which means 1 plus, remember, right? Width plus 0.1 W, that's the increased part. It's going 1.1 W, right? Okay, it's increased. The length is decreased, L minus the decreased part, which is 0.9 L. Okay, so this is our new length and new width. So the area, so this is the area, change it to A prime, right? The original area is L times W, right? This will be L prime W prime. We have to do some more short way, right? So you don't need to know the exact value of the original length and width. You just use a letter to describe, denote it. So you get 0.9 L, right? 1.1 W, right? So you multiply them out, 0.9 times 1.1 L times W. So this is going to be what? 1.1, 0.9, right? And 0.99. And LW is the original area, right? So the new area is equal to 0.99 of original area, a decrease. You can even tell decrease by 1%, right? You can, because this is going to be 1 minus 0.018. So decreased by 1%. Okay, yeah. So you don't need to know the exact value, but sometimes you want to know, you want to do calculation quickly. You are not familiar. You gradually have to get used to use letters, not in the specific numbers. Then you can make a special example. You can assume, right? You can assume the rectangle and the length is 20, the width is 10. That's so fine. Okay. Then you change to, then you change it to, yeah, width increase by 10%. It's going to be 11, right? Right. This decreased by, this is a little bit difficult. So 0.9 times 20. Then you do the calculation. This is 10 times 1.1. Okay. Then you still get the same result. Okay. This is the area, so it's going to be 200, and this area, you just look at the product. Okay. And if you want, you can do the product as 10 numbers. Okay. And you will see it's a smaller number. It's the same. Okay. But it's not necessary to give a sign special value for the length and the special value for the width. Okay. Yeah. So all right. So the next problem is okay. If the length of the diagonal of a square is double. Okay. What is the ratio of the area of the new square to that of original square? Right. So this is a little square, right? And you double. Okay, this is a D. That's a 2D. Mm-hmm. You have to prove your statement, Yeah, you should know. Yeah. Why there? You see, you're given the length of the diagonal double, right? And this is the area, right? And this is a new area, right? I want to find the ratio. Okay. So if you are able to express A in terms of D, yeah, let's try this, okay? I know some of you get the answer, okay? Let's express A in terms of D. The area can express in terms of D, okay? It's actually going to be, you see, if this side is A, right? This is A, right? And you will see that A is going to be A square. But D is going to be, D square is going to be A square plus A square is 2A square, right? So that means A is going to be half of D square. So the area is always equal to half of the length square of the diagonal, okay? So clearly, right? So the ratio here, what is the numerator here? The numerator is half of double the D, right? And then this is going to be the original D, right? And after simplifying, it's 4 to 1. This cancel out. Then you get 4D squared D squared, and that is 4 to 1. Yeah, but you can also use a specific example to find the answer. You know the answer if the answer is definite. Sometimes you can say you cannot determine. Okay, for example, this is a 1. This is a square of 2. When you double it, right? And actually, it's a 2 square of 2. How do you get 2 square of 2? If this side is 1, this side is 2. So clearly, the area is doubled. You know, the area is going to be, everything is doubled, then the sides also doubled, right? The length of the diagonal is doubled, then the side is also doubled, okay? That's why the ratio is 2 square to 1 square. It's a 4 to 1, okay? You can also quickly get the answer. Okay. Right, let's do one more example. So if if the diagonal of a square is 7 square root 2 centimeters long, okay, and what is the area? Yeah. Now you can forget this original. Well, you can forget the formula. You should know the basic formula, right? You draw the. If you know the edge length, find the edge length first. Like that's my suggestion, right? You write. Yeah, if you choose a problem, draw the picture first. Write down the formula for the area you know. That's a square. Write down the formula for the length of diagonal. It's a square root of 2 times a. Okay. Then you look at what is given. I'm given the diagonal, the length of the diagonal, which is a 7 square root 2, right? Then clearly the age should be equal to 7. Then you use that to find the area, which is 49. Yeah. Yeah. So you draw the picture first, and write down the formula you already know, but they're not directly given. You know, the data is not directly given for you to find the area. So you have to find the edge length first. Those are we call the two-step problems. In my advanced class, we're going to study a little bit more difficult problems. You cannot just solve it directly like this. All right. All right, so I have a rectangle. Okay, I know the area. Okay, is going to be 60 square meters. I also know that the parameter. This is very good. The parameter is going to be okay. Can we find what is the length of the diagonal, or the dimension of the what's the length of the diagonal? Okay. Yeah, what is the dimension of the rectangle?
The length is 5. I mean, the length is 5. Oh, the width is 5. Yeah, I know. That's what I said.
How do you do that?
Well, because 34, 60 can be made from like 20 12 is 5. So then 12 plus 5 is 44. And 5 plus 5 is
All right. So you remember the special right triangle. Otherwise, how do you know this is a unique solution, right? In mathematics, I'm not asking you to, it's possible I have 2 solutions, right? Remember that, right? So yes, this probably is one of the solutions because you solve the problem because you memorize the special right triangle. This is what I suggest: memorize a few right triangles that can quickly solve the problem. So if this side is A, this side is B, we know A times B is 60, right? And then A plus B is half of the parameter, which is 70. Okay. Then you're trying to figure out, is there any 2 positive integers? Okay, is there any 2 positive integers for you to figure it out, right? The length of the diagonal. Okay, and it's yes, in this case, this is this is going to be 12 plus 5. This is 12 times 5. So okay, then I think A should be equal to 12. B is 5. We are lucky because I carefully choose these numbers. Okay, so this is going to be, A is going to be 12, and the B is going to be 5. And therefore, you get dimension, so you get the length of the diagonal. Okay, now what I want to tell you is, if you are not lucky, okay, 60 and 70 cannot be written in such nice product or sum. Okay, what is the way to how to find the how to find A squared plus B squared? Okay, how to find A squared plus B squared? Okay, if 60 and 70 are changed, if 60 change it to 61, I can do that, right? Or 70 change it to 15, right? If like a 70 is changed to 15 or any other numbers, right? Are you able to still do it using now you try that you just waste of time. You trying to record any specific triangles or trying to factor this, because if it's 15, then 15, 12 times 5, add them together, it's not going to be 15. Okay, so there's a very important formula in mathematics. Everybody, if I write down, you know this. Okay, if a plus b squared, can you expand it? How many of you can do that in this class? Can you write down this? Yeah, write down this expanded. Okay, if this is a homework, you know, ask you to expand this. This is algebra. It's the very most simple fundamental formula in algebra. Are you able to write down this formula? Yes. If you don't know, that's okay, but you should know how to multiply this out, right? A plus b times a plus b, right? Then you product, it's going to be a square, then times ab, right? And plus ba, and the bb, the b square. So you reorganize it, it's going to be a square plus b square plus 2ab, right? Yeah, but when you come back to the rectangle, here's a, here's a b. What do you see? A plus b is half of the parameter, right? A square plus b square is the square of the diagonal. A times b is the area. So the diagonal, the length of the diagonal, the area, and the parameters are related by these algebra equations. Okay, so if you are given two of them, you should be able to get the other one. Okay, let's look at this. Okay, so if area A is going to be, I just modify this, you know, originally I give it 60. You know, I can set here 60, okay? If area, right? And then, and the parameter B, the parameter P, right? It's going to be, here I put a 70, right? 34, I put 40, okay? Okay, I want to find the length of diagonal. And look at this. Half of the parameter is 20 square, a square plus b square, and the 2ab is 60, right? So, and then you can a square plus b square equals 400 minus 120, right? And that is going to be 280, right? Yeah, 280. Yeah. So 280. This is a square of the length of diagonal, right? And that's going to square of 280. Okay. Question: can you simplify this square root? You get an irrational number, okay? But using the above fundamental identities equations, you are able to tell the relationship among the parameter, area, and length of the diagonal. Okay. No, square root of 280. How do you simplify it? Okay. Say factor 280, right? 4 times 7 times 10, right? Yeah. So at least the square of 4 is 2. But square root of 4 is 2. But 7 times 10, I cannot take out anything. Okay. 10 is not going to be any, right? So it's a square of 70. This is simplest form you can write. Okay. Yeah, this is simplest form you can write. Question. Square root of 70 is between which two integers? Yes.
8
and 9. That's right. Because 70 is less than 81, greater than 64. All right. So between those two perfect squares. So 64. Yeah, this is a 9. This is an 8. Okay. So sometimes you do need to do rough estimate about the the square root of the some number. Okay, you just find out this is between two perfect squares, then you can solve the problem. Okay. All right. Okay. So next problem, that's easy. Let's do this first. Okay. I know this is a 5 meet, like some pool here, right? This is a 2 meet. Okay. What I'm going to do is I'm going to increase yeah, put the sidewalk around this pool. Okay, this is a pool. Okay, and put the sidewalk, and the sidewalk is going to be half of the meter. The width is half, 1/2. Okay. Okay. Yeah. Okay. So my question is, what is the area of the sidewalk? Yeah, the width of the sidewalk around this pool is going to be half meter. Okay. Okay. So what is the area of the sidewalk? Why you needed to know that? Suppose you have a swimming pool, right? You build a swimming pool, and you measure the dimension of the swimming pool. Then you go to the store to buy bricks to cover, build a sidewalk around that, right? But you need to know the area, because you look at each brick, how large of the area each brick, then the total area sidewalk and divide by the area. Then you need to know how many pieces you're going to buy, right? So this is very simple mathematics. You have to do the calculation before you go to the store. You cannot buy too many unless you have to go to another, go twice, or you have to return the material, or you have to buy more. So you have to do rough estimate. You can add a couple more bricks just in case it is broken, or then you can reserve that. But you should get a rough estimate. Okay. So the area of the sidewalk is important to calculate. So what is the best way to do that? Give me the answer. You're not sure, do the calculation. Hmm? So if you cannot do this, that's all right. You cannot do the construction work. Right? You do need to do the calculation. Simple calculation. Come on, quick. All right. Anyway, well, so the best way to do this problem is use a subtraction. Okay, because otherwise, you see, you have to divide the sidewalk into many rectangles, squares. Takes too much time. So This side is going to be 5 plus 1/2 is 1.
Oh no. Again? Yeah, again. Yeah.
No.
Benjamin, go. Question.
Okay, should be okay now. I touched the bottom somewhere. Yeah, I'm okay. It's still. All right, so this is a 5 plus 1. It's 6, and this side is 2 plus 1. Oh, this is a. I don't know what's going on here. Yeah, this is a problem. Hmm? No, sometimes you. No, sometimes we have problems with this program. Yeah, I remember this last time. Whenever I write on screen. All right, so let me complete my explanation before I write on the screen. Okay, I hope that's not the worst case. All right, so the side length is going to be the larger rectangle. Okay, the larger rectangle, the length is going to be 6. The width is going to be 3. So 3 times 6 is going to be what? 18. Then you subtract 10. Then that is 8, right? So you get 8 square meters. Then you know how much material you're gonna buy. Okay. I have a question. Okay, write down carefully. Okay, listen. Before I write, if I go to the store, I forgot the original dimension of the swimming pool, but what I remember is the perimeter of the swimming pool. Okay, I remember the perimeter of a swimming pool will be 20 meters long. Write down that. Okay. So okay. The perimeter of original swimming pool is 20 meters long. The reason is that's what I remember on my piece of paper. I did not write down the dimension. I want to build a sidewalk around that, which is 1/2 feet wide. Okay. The question is, can I still figure out the area of the sidewalk? I only know the perimeter. I don't know the length, the width. Should I go back to home to measure it, or I stay there to do the calculation? do that, okay? Yeah, are you able to figure it out or not? Okay, do the computer. I'll give you a minute, okay? Remember, right? The perimeter is 20 meters long, okay? The perimeter, that's only you remember, okay? You forgot to measure dimension, okay? Okay, that's what they remember. Okay, if it's possible, not impossible. And then what is the area, okay? Do the computation. Yes. Yeah, but that's right. It's connected.
Exactly. So but we're not on percent.
No, you can do that, okay?
First of all, why do you want a sidewalk right next to you? Would you rather step on hot car?
You need a sidewalk, okay? Otherwise, right, you can assume the swimming pool have a certain dimensions, but the question is whether this is your answer will be independent of the dimensions or not. Otherwise, it could be different dimensions, right? With the same parameter, right? I said that the parameter is 20. but then 5 plus, 5 plus 5 is a square, right? 5, yeah, 5, 5, or it could be 7, 3, right? Yeah, 7 and 3 is also to give you the same parameter 20. You look at those two, okay? As a biologist, probably do like this. Two different examples. I'm doing experiment. It's a square, 5, 5, then 8.5 inch on each side, and did the calculate. Then have a 3 and a 7, right? It's also given us parameter 20, and you do the calculate, you find, oh, it's the same. Okay, then in conclusion, we write a paper, say, okay, it's always the same result. That's our discovery. Okay, mathematicians will say, no, that's not proof. You only choose 2 examples. There are millions of different sizes of rectangles with the same parameter. So you only prove that those 2 special rectangles give us the same answer, but does not mean about the other rectangle with the same parameter. Okay, so work on that. I'll give you a half a minute, 1 minute, give you do the problem. All right. All right, so let me show you how to do this. Okay, if you're not able to do that. Okay, so we don't know whether we are able to solve it. Let's see. Okay, you don't know the exact length and the width, right? And x and y. Okay, but the all side the rectangle is x plus 1. This will be y plus 1, right? We use the same idea to do the difference. Okay, so the area of the sidewalk is going to be x plus 1, y plus 1, right? Minus the area of the inside. Okay, the inner rectangle. Can we determine it? Right? So let's do the multiplication. The 1, x times y, x times 1, 1 times y, 1 times 1. Sorry, this is the one. That's the reason I'm scared of it. I have to restart my computer, but not right now. We're almost done. Okay, so you take the difference, and you will see it only depends on x and y, x plus y. Okay, and plus 1. Okay, x plus y, and yeah. So you will get x plus y, x plus y. You expand, okay, multiply them out and simplify. Can you do that? Yeah. Do the calculation, you guys. This is algebra calculation. Multiply them out and the simplified. What is left is x plus y plus 1. But x plus y is half of the parameter, right? Which is given, which is 10. 10 plus 1, so 11. So 11 square meters. So that's why how do you figure out the, yes. Yes. So this is going to be, after you simplify, it's going to be x plus y plus 1, which is 10 plus 1, 11. Okay. So the area of the 11 square meters. All right. So the shape, the area of the interior inner rectangle cannot be figured out. Okay. Why? Because you only know the dimension, right? Dimension is just x plus y. So you cannot figure out x times y without additional information. Okay, that could be in mathematics. There are many problems like that. Yes, you know that it cannot be fixed. The dimension can be fixed, but then you're still able to get some other information like area. Okay. All right. So we will go back to the triangle. Triangle. Do you remember the formula for the area of the triangle?
No, it's the area of the. Yeah.
So the area is going to be half of the b times h. But are you able to prove that? Because we only define the area of the rectangle. Yeah, how do you prove this? You know, you cannot just memorize. Maybe this is the wrong formula, right? How do you know this is the right formula, right? For example, I give you 2 pieces of cake with a rectangle. Other one is triangle. And you use those 2 formulas to do cake ratio. Okay? If the formulas are all correct, then if you get the same number, then you know these 2 different cakes are same, right? But if the area formula for the triangle is incorrect, then even get same number, they're not necessarily the same. So you shouldn't know this. We call the formula. It's not definition, but the area of the rectangle is definition. In mathematics, definition is different from the formula. Okay, and we define the area of the rectangle x and y as a equals x times y. That's the definition. We use that to measure the size of all the other type of figures, including the circle. Okay, it took very, very long time for human beings to figure out the area of the circle. Okay, because it's not a rectangle, right? It's not a rectangle. Think about how to figure out the area of the circle. Don't look at textbook, okay? But let's look at this triangle. The triangle, in order to find the area of the triangle, when you do that, you cut. Okay, you keep this part, then this part is moved to here. Okay, this is let me check where we should put it. Okay, we have to put double this. Okay, so we double the triangle, but first cut in the middle, right? And then this is a B, right? So area of the rectangle is going to be B times H, right? Half of that will be the triangle. Why? You see that this is a half, right? Other side is also half. Left side is half. So that's the reason the area of the triangle is going to be half of the area of the rectangle. B times H represents the area of the rectangle because H is the width of the rectangle. B is going to be the length of the rectangle. So it's just like a puzzle, you know, you put it there, okay? And so if the 2 triangles have same area, then they have the same they have the same, no, if they have the same height, then just look at the space size, okay? I give you, assign the problem, I ask you to do this. Here's a triangle, okay? I don't give you the height. What I know here, this is a 2, that's a 3. If this is 2 cm, this 3 cm. This is a 2 cm square, and this is what is the area of this part. Okay, you think about that. We come back to do this part. Don't just jump to the house. That's not how it works. Okay. Okay. So this is a problem you have to think about when you get home, but also you get a homework assignment. Okay. So let's stop here.